Okay, the recording has been started. Okay, can someone please confirm if my screen is visible? Are we good to proceed? Okay, thank you for the confirmation. So let's do a quick recap about the yesterday session. So yesterday what we are discussing, we have just started discussing about how to create a Java package, right? It's very easy, right? How to create a Java package. So we need to use a keyword called package keyword followed by the user defined name. Any meaningful name you can give. Okay, and always remember this package creation should always be the first line of the Java program. Okay, you have to place this package keyword. It should always be in the first line. You should position this package keyword in the first line of the Java program, right? The moment you include this keyword, okay, there will be little changes with the compilation. How do you perform the compilation? The typical compilation command is what? Java c space hello.java. We know this already. But when you are including this package statement, okay, when you're including this package section, I can call it as the package section. The compilation command is going to be little different. Okay, as usual, to activate the compiler, the command is going to be java c, right, in the command prompt. So this is going to activate the compiler, followed by you have to give a space followed by -d. So d is representing what, in which destination you want to create the package folder. Okay? And what you would say in the current destination. So to represent the current destination or the current working directory, you simply place an operator called dot operator followed by the class name.java, the respective file name. Okay, this command is going to perform two operations. One is what, the package creation, and the second one is what, it will also perform the compilation. Okay, the dot class file is going to get generated, that is going to get placed inside this package called mypack package. After that, okay, you need to perform what, execution. How to perform the execution? The typical command, this is the general, with the packages, if you create the package, this is the command to perform the execution. Java space mypack is the package name. Inside that you have the dot class file name, right? So this is how you perform what, execution, right? And we have also understood, right, what are the, if someone is approaching, for example, if I own a company like Balaji Infotech Private Limited, this is my company name and this is the client name. A supermarket dealer, he wants to develop a calculator application. So these are the functionalities that you want to add in the calculator application. So there is a person called product owner. Okay, product owner is part of the company, but he is going to collaborate with the client to gather the requirements or to understand his requirements. After the collaboration, he is going to give this as an input to the manager. Okay, and under the manager, usually there will be many teams working under one manager. So in our example, we have taken 3 teams, alpha, beta, and gamma. Right? Under each team, there are two sides. One is front-end developers and back-end developers. So we are learning Java, so we are back-end developers. Under back-end developers, there will be one team leader. Under each and every team, there will be some developers, back-end developers, right? So this task will be assigned to the back-end developer through product owner, through manager, through the respective team leader, followed by the respective developers. Okay? And the task numbers will be given according to the team name. If the team name is alpha, alpha followed by some random number, story numbers, you can call it, or you can call it as a task number. Okay, through this task you can identify what kind of functionality that the developer is working upon, right? So Lakshmi is working upon addition, Monica on subtraction, Prasanna on multiplication, Ajay on division, right? So what they are going to do, they are going to create the functionality and they are going to place that functionality in a separate package, individual packages. Addition will be placed under a separate package, subtraction, multiplication, division, individual packages, right? After the requirement is done, after the development is done, the team leader is going to do what? The team leader is going to create a main class and is going to test all these functionalities. Okay, this is what we have discussed in the yesterday's class, right? And I have also introduced about what there are three types of projects. Okay, the project that you develop from scratch. Okay, you call it as what, scratch development project. And there is another project called maintenance project. Okay, majority of the software industry, they are dealing with the maintenance project. 90% of the projects are working upon maintenance. And the migration project. Okay, migration projects are like, if you want to migrate from one tool to another tool, or one technology to another technology, right? So those projects are comes under migration project. And in the maintenance project, okay, the project is already there. You will add new functionalities, you do some kind of enhancements, you do some kind of code improvisation, things like that you're going to do. Maintenance project. Scratch development is developing the project from the beginning, right? And this is how the hierarchy is going to be in any company, in any software industry, starting from the software engineer, okay, and senior software engineer, team leader. This is the hierarchy ladder, right? In some companies, they call software engineer as associate consultant, senior consultant. Okay, so they follow that hierarchy, but this is how it is going to look like. This is how the hierarchy is going to be. If you want to place experience of 4 years or 5 years, okay, you can try for senior software engineer. Or if you want to place experience more than 6 years, you can try for team leader. This is how the hierarchy is going to be, right? So this is what we have just understood about the package creation. Today we are going to see these things in detail with respect to the real-time project. Shall we proceed? Type yes in the chat box if we are in the same page. Are we in the same page? Yes, no? What is 1 minus 1? Everyone? 1 minus 1? Good. What about others? Everyone type in the chat box so that I will get to know that we are all on the same page. Okay. Good. Okay then. So let's continue. Let's continue discussing. So today I think it's class 18 if I'm not wrong. Yeah, I missed one recording. Okay, that recording was not part of my playlist. So I think class today is the 18th class. Correct me if I'm wrong. What is the Java package? Okay, so if you see this, today we are going to discuss something very important, okay, with respect to the real-time application. The Java package is a collection of similar type of class. And also these are the advantages of creating Java packages. What are the advantages? Reusability, modularity, security, shareability, and abstraction. Actually, we have understood about reusability. Today we'll understand about modularity. So let me take this piece of line and put it in the paintbrush. Okay, what is this? Class 18, isn't it? So class 18. So this line is very important. Okay. If the interviewer is asking any question, what is Java package? This would make more sense. Answering this line would be sufficient. For some panel, they go deep into the packages. So you want to explain them in such a way that you have understood the concept of packages. So what does it really mean? Look at this line. Similar type of classes. Okay. So let us understand this better. So yesterday we have understood that if you are getting a project, okay, and if the project will be separated into many modules based upon the requirement. So what was the actual project that we are actually working upon? As per our assumption, we are working upon what? The calculator application. Calculator application, isn't it? Okay. The moment you receive the requirements, right? So what your TL is going to do? Your TL is going to, divide these projects into bits and pieces into several parts according to the requirements. What are the requirements? Requirements are like there should be addition functionality, subtraction functionality, multiplication functionality, and division functionality. There are only 4 requirements. So the entire project gets divided into 4 parts, right? So this is one part, right? So this is going to be one part, and this is going to be second part, okay, and this is going to be third part, okay, and this is going to be what? Fourth part, right? And so the team, this is the job of the team leader. What team leader usually does, he divides the entire project into several parts, several modules, I can say, several modules. So what is one of the modules? Addition module or addition functionality implementation. Okay, what are the other modules? Subtraction, and what are the remaining two? Multiplication, right? We are not discussing what we have discussed yesterday. It looks like that, but this is something different. Multiplication. Okay, and what is the remaining one? Remaining one is what? Division. Okay, so your team leader is part of a team name called what? Alpha. Alpha is the part of what? Alpha is the name of the team. Okay, this is the task number. Alpha 1 2 3, Alpha 4 5 6. Okay, and again you have what? Alpha 6 7 8. Okay, and again the last one you have what? Alpha 1 1 1. This is the task number. So the the entire project has been separated into many modules, 4 modules, because there are only 4 functionality that is expected from what? From the client, right? And what your TL is going to say, your TL will ask you to place the .class files in a common package. Your TL is going to ask, your TL is going to say, okay, everyone has to use a common .class file. I mean, common package name. Everyone has to use what? Place the .class file in the common package name. Common package name. Package name has to be common. Why the package name has to be common? Right? If you look at the functionalities, okay, addition is one of the functionalities. Subtraction and multiplication, and you have what? You have division. Okay, these all functionalities are similar functionalities. They are not similar because of their function. They are similar because of the nature. What is the nature of these functionalities? To perform what? To perform arithmetic operation. To perform what? Arithmetic operation. Every functionality will perform arithmetic operation, right? So addition, subtraction, multiplication, division, basic max, basic arithmetic functionality. So what your TL say, since all the functionalities are performing a common operation, place all those functionalities in a common package. Able to follow? Okay, so it is your responsibility, each and every team member responsibility, to place the individual functionalities into a common package. Why common package? Because the functionalities are similar in nature. They are not dissimilar. They are similar in nature. They are similar in nature according to what? The nature of the functionality. What is the nature of the functionality? Calculating. Right? He asks each and every team member. Okay, let us say that this is being worked upon by Lakshmi. Right? So now what Lakshmi has to do? Lakshmi has to use the common package that was specified by the team leader. Team leader says, hey Lakshmi, once after the development, try to place this inside a package called the calculator package. Right? And everyone has to place what? Their development. After the development, everyone has to place the .class files into the common package, which is called what? Calculator package. Right? How we are supposed to do? Okay, let us say that Lakshmi is working on this task. So package. Okay, since Lakshmi is going to work based upon the expectations that is given by the team leader. Team leader said what? Place it in the package called the calculator. Okay, package has been created. Then what Lakshmi is going to do? Lakshmi is going to specify a story number. So what is the story number? Alpha 123. ALPHA 123. Alpha 123. In the single line comments. Okay. What is a functionality that Lakshmi wants to develop? The addition functionality, isn't it? So Lakshmi will create a class, okay, public class, and the name of the class is going to be addition. Right? So, and followed by a simple method, public static void main. Okay, and this method is going to accept 2 inputs, integer a comma in the form of integers, right? And it performs the addition operation. Okay? And the resultant value is going to get assigned to a variable called C. Okay? And at the end, you are going to display the result in the console. System.out.println. Okay, after performing the addition, it is just like this, guys. If you want to imagine this, okay, Lakshmi is developing a functionality which accepts 2 inputs, input number 1 and input number 2, and it is going to give 1 output. Okay, and she is writing some kind of code inside. What this code is going to do, whatever the input that you give, okay, if you pass inputs as 10 comma 10, 10 and 10, okay, and the output has to be what, 20. Okay, these inputs you pass in the method parameters. Okay, this output you can either return it or you can print in the console. For now, these two inputs are talking about what, the numbers that you're passing as an input. Okay, and the output that you're receiving here is what, it is getting received in the form of console. This is how you can imagine. Okay, she has done this. Okay, so the code has been written in the notepad. Code has been written in the notepad. You want to instruct your machine, you want to ensure that your machine is understanding that this is a Java code. How you will give that ensurement, how you will give that, how you will convey that, this has to be saved with what, the .java extension, right? I'm going to go to file, save as. I'm going to tell my machine, hey machine, this is not an ordinary file, this is what, this is a Java file. Okay, use .java. Okay, what should be the name of the file? It should be same as the class name. What is the name of the class? Addition is the name of the class, isn't it? Addition. Okay, the moment you do this, the moment you click on save button, okay, and if you go back to the folder, okay, where is that folder? D Java. Okay, there is a file created. What is the name of the file? Java file. Okay, after this you need to perform the compilation. Anyone remember what is the command, what is the command that we are going to use for the compilation when you have a package? Can anyone help me with that command? Anyone, anyone, what is the command for the compilation? I'm expecting answers from you. Who's going to answer it? Yeah, Teja, yes, correct. Java C space addition.java is the basic command, but when you are using the package, okay, Sudhir is correct. Sudhir is correct. Correct. Prasanna is also correct. See, what I'm trying to say is, if you are not creating a package directly, you can use Java C space class name Java, but you have a package here. So whenever you are having a package, okay, the typical command has to be what, Java C. You are activating the compiler followed by what, hyphen D. Hyphen D is what, you are specifying the destination, in which destination you want to create the package. Okay, I want to create my package in the current destination. Okay, then use dot. Okay, followed by which file you want to compile. Which file you want to compile? I want to compile what? I want to compile addition.java. Addition.java. Okay, let me get this for you. Then what the machine is going to do? What the Java software is going to do? Okay, Java software is going to create a package, calculator package. Inside this, the dot class files will be placed. Are we clear? So this is how you create the package. Making sense, right? Nothing is there. Okay, you have to just follow this command. That's it. So the what we call it as, Lakshmi did what? Lakshmi has done her job and ensured that the dot class file has been successfully placed in a package called the calculator package. And the next person, the next developer should also follow the same things. Okay, next developer should also follow the same things. Okay, Lakshmi job has been done perfectly. Who is the next developer? Let us say that next developer is Prasanna. Okay, Prasanna's task is to create a method that performs the subtraction operation. Very simple. I'm just going to copy this. Okay, I'm going to create a notepad. Okay, and this time instead of addition, I change it to what? Subtraction. Okay, and two inputs are being accepted. I will just change the operator to minus operator. Okay, what is the story number of Prasanna's? 456, right? And I will perform the compilation. First, I need to save this. Okay, this is a piece of code in the notepad. Let me save this file. Save as. Okay, so you should convey this to the your system. This is the .java file. I mean, this is Java file. So subtraction.java. Okay, after this again compilation, Java d space hyphen d space subtraction dot. Okay, let us see. if the dot class file that has been generated is placed in the calculator package. You go and see the Java file is outside, but dot class file is inside the calculator package. So addition dot class file is already there. Now the subtraction dot class file. Like that, the remaining two developers tasks are pending, right? Okay. Who are they? The third developer. Let us say that third developer is Sudhir, who is working on the multiplication operation. Usually in the real time, you don't use command prompt, but this understanding is important to create the packages in the real-time application. That's the reason why I'm taking you deep. We are just doing the deep dive. Now, Sudhir is going to perform the multiplication. I'm going to copy the same thing, okay, and put it here. Okay, I will just change the class name multiplication, right? Multiplication, okay, and the name of the task name is 789. I will just change the operator to into operator, right? I want to save this file, save this, save us. After writing the code, saving is mandatory. Okay, what is the naming convention? Multiplication followed by .java extension. Saving is done. Source code has been saved successfully. Now we need to perform the compilation operation, right? To place this in the common package which is called calculator. Okay, and Sudhir job is also successfully done. So where is the proof? If you see inside this calculator folder or package, you can see multiplication dot class file. Okay. The last job is pending. Okay. Where is the last job? Division job is pending. This is done and division job is pending. Okay. Let us say that this division job is being assigned to Dinesh. Right? Same thing. We do it really quick. Task number 111. Name of the class is what? Division. Right? And I will just change the operator to forward slash, which is representing the division. Okay, I want to save this file, save as, okay, division.java, division.java, okay, compilation, okay, division.java, done. So if you see, so in the common folder, calculator folder, there are 4 dot class files, right? Now can I say that, okay, package is the, okay, calculator package, here the calculator package is the collection of similar classes: addition, division, multiplication, subtraction. Not similar by their functionality, but similar by their nature of functionality. Okay, and if you go back and see the theory, if you go back and check the theory, so what was the actual theory? Now see, a Java package is a collection of similar type of classes. So forget about this, forget about these two lines, interfaces and some package. We are going to discuss this, the future topic. Okay, now this is giving the justification. Okay, after the development of this functionality, right? And what the TL is going to do? TL is going to accept each and everyone's functionality. Okay? And every functionality needs to get combined as a single entity. Okay, they are in bits and pieces, right? They're in bits and pieces. It has to get combined, or it has to get what we call it as combined. I can say combined into a single unit. Okay, single unit as a whole. So you're representing this thing as a whole. You're dividing the task into 4 modules, and after the task completion, what you're doing here actually, you are the TL is going to combine all the tasks into a single entity, right? Dividing the task and functionalities into bits and pieces, and then after it, once it is developed, you're combining all the functionalities together into a single entity, so that this is going to represent a whole functionality, whole thing as a single functionality. Or I can say that it is going to represent the functionality as a whole. You call this process as called the modularity. This is called as what? The modularity. So what is modularity? Okay, if I go back and show you, okay, look at the theory. What is modularity? Dividing the task or functionality into bits and pieces. First of all, okay, we have divided into 4 parts. and after it is developed, okay, after it was developed successfully, combining all functionalities together into a single entity. We combined everything. Okay, so that is going to represent the functionality as a whole, a single functionality. Okay, this is called as modularity. And how we are achieving this modularity? This could be achieved with the help of packages. Are you able to follow? Now you got to understand what is modularity. Don't you? Yes, no? Have you understood what is modularity in Java? Modularity is making sense? Ah, good. Okay, now let me put this in the paintbrush. Modularity. Okay. So after achieving modularity, modular is one of the advantages. Modularity is what one of the advantages. After achieving this modularity, and what you want to do, you want to use this functionality, right? You want to test this functionality. You want to test this functionality. So before even testing this functionality, you should be in a position to what? Access the package. So every dot class file is placed in a typical package called the calculator package. Okay, this calculator package has many 4 dot class files. Each and every dot class file is representing a single functionality, right? So you should create another class to access each and every functionality for the testing, right? You should create another class to access each and every functionality for testing, right? I can also say that how do we access one package from another package? How to access this package from another package? The question is, okay, this one. How to access a Java package from another package? There are three ways. There are three ways to do so by using the import keyword. Now import keyword is coming into the picture. You can use import keyword in three ways. The first way is, okay, just use the import keyword followed by the package name, okay, and you use the dot operator followed by the asterisk. We will understand each and everything. Second thing is package name dot the respective class name. Third thing is by using fully qualified name. Let us put this in the paintbrush. Okay. The question is, we have understood modularity. The second one is how to access the Java package from another package. I want to test this. I have just created classes. What is the point of creating each and every class and functionality? I need to use this, right? In order to use this, I need to do what? I need to create a separate class, and I have to import each and every package by using from another package. So this is how we import. There are three ways to do the import. We'll understand one by one. So in order to do this, I need to create a main class or the driver class. Now the question is, what is the driver class? Is the driver class. Okay, so who has given you this task? Your team leader has given you this task, right? Your team leader is going to test this job, okay, whether these things are working successfully or it is not working successfully. He is going to test this. Okay? He will test this by using a class called driver class. Okay, what is a driver class? This is a class which is going to have the main method. Any class that is going to have the main method is called as driver class. Why main method? You can execute the program, you can execute the task only from the main method, because this is where the execution starts. Okay, now what TL is going to do? TL is going to be very happy that you have created the developers has completed the data. Now the TL job is to what? Create a common class. Okay, you will create a common class. Okay, to test what? To test all the functionalities. This common class is going to have what? It is going to have a method called main method. Okay, is going to create a package, some kind of package like package, class, something, a random class or package application. Because application is completed, so it's going to create a package like application. It's going to have a class like, the name of the class is going to be what? Class cals. Cals is representing calculator and is going to have the main method public static void main. Right? Okay. So let us design this. Okay, so this is just for our understanding, a pseudo code. Let us design this. Now TL is coming into the picture, package cals. Okay, and TL is creating a driver class. Driver class is a class that is going to have the main method. Okay, I'm going to give the class name as what? The driver. You can give any meaningful name. okay, or else you can give like, let me keep it as a driver itself, right? After this, what your TL is going to do, TL is going to say, you're going to keep a main method public static void main, okay? Now focus here, this is very string array ops, right? You want to test the addition functionality. You want to test what? You want to test the addition functionality. This functionality you want to test. The additional functionality is part of what? Addition class. Now you see this code. If you look at this code, let me put this code. Okay. Okay, this is your TL code. Now TL is trying to test Lakshmi's code. TL is trying to test whose code? Lakshmi's code. Because Lakshmi has developed the addition code. I mean the functionality for the addition. Right? This is what the Lakshmi's. Okay, how this code can be tested? Okay, so the moment the TL performs the compilation, okay, so whenever the TL is writing a piece of code, that code needs to go through what? It has to go through the compilation, right? Yes or no? It has to go through what? The compilation. Let me, okay, it has to go through compilation. Compilation, right? After compilation, okay, execution. Execution means a main thread will be created. A main thread will be created. So main thread will get access to the main method. Right? Main thread will get access to the main method, but inside the main method there are no instructions. Very empty. So output is going to be empty. But the TL wants to test the functionality of what? The addition. So for now, just keep in mind, in order to do that, you need to create an object. Why we are creating an object? Forget about it. You want to create an object because after creating an object, he will get access to this particular method, addition method. You want to create an object for the class where the functionality is, where for which functionality you want to test. For now, creating object is mandatory. Why creating object is mandatory? Why we are doing that? We will understand later. But to get access to this addition functionality, he has to create an object. How the objects can be created? Okay, name of the class addition obj equal to new keyword followed by class name addition. Okay. If you give this instruction to the compiler, if you give this instruction in the main method, if you give this instruction inside the main method, this main method will not recognize what is this addition. It will not understand. Yeah, you are saying addition is there, but where is this addition? Addition is not part of your current class. I'm not able to see where is this addition. Okay. To ensure that your main thread is recognizing this addition, you will use a statement called the import statement. You will say what? You will write a statement called import statement followed by addition. This addition is part of which package? Calculator package. Okay. You will give the directions. That's it. You will give the directions. Okay. Main thread, there is a package called calculator package. Okay. Inside this calculator package, inside this means dot. Inside this calculator package, there is a class called addition class. Okay. The moment you give this instruction to the JVM, the moment you add this instruction, the moment you add this import keyword, okay, now the JVM will understand, oh, this person is creating an object for a class which is part of what? Which is part of the calculator package. Okay, inside that calculator package there is a class called addition class. Now main thread, now you are just like creating a way. You are creating a way between these two classes. Okay, a way is created. Okay. Now what it will do? Okay, it will identify, okay, it will recognize, okay, there is an addition class through this import keyword. Okay, now it will get access to this addition class. After this, once after getting this access, you need to do what? It will recognize, then you need to do what? You need to transmit this control to this addition class. How do you transmit the control? Okay, simply by using this object reference. Okay, this is the object reference obj. You would say obj dot get access to the method. Okay, why did I use the main method as method as main here? Should not be main. I'm sorry about this, guys. Should be add method. Okay, just a small correction. Okay, this should be sub method. Okay, this should be triple method. Okay, this should be division method. Let me save this. Give me a moment. Let me correct this. I have saved everything. Let me recompile this. Division.java, abstraction.java, multiplication.java, and division.java. They are not main methods. They are the user-defined methods. My mistake. My bad. My bad. So this is what? This is not the main method. Okay, this is what user-defined method, which is add method. Right now, you would say, okay, inside this addition class, you are saying you're directing the main thread to get access to the add method, and here you will pass inputs like 10, 10. Any numbers, any two numbers you will pass 10, 10. Okay, this 10 will get assigned here, and this 10 is going to get assigned here. Okay, now the control gets transferred. Okay, from here to it gets transferred here. Okay, and this it will also assign the values 10, 10, right? So this 10 internally gets the mathematical operation. 10 A is 10, B is also 10. Okay, 10 plus 10 is going to be 20. This 20 will get assigned to C, okay, and output 20 will be displayed on the console. Right? What is actually happening? The team leader is trying to create the driver class, but he wants to get access to a class that is inside a different package called the calculator package. To get access to to create this barrier, to create this barrier, I mean, to create a connection, you would use what? You would use the import keyword, right? So now the TL intention is to test only the functionality of addition. What he has to do? He has to import the addition functionality, which is where the addition functionality is placed inside a package. What is the name of the package? Calculator package. Inside that there is addition class, right? Yes or no? Right? Now import calculator dot addition. The moment you do this, now this class has complete access to this calculator package, and it has access to only addition functionality, only one functionality, which is addition. Okay, making sense? Okay, now you create an object for addition. Addition obj equal to new addition, right? Obj dot, what is the name of the method in the addition class? Add method, right? Let me copy that. Obj dot add. At any two numbers you can pass 20, 20. Okay. Now what would be the output? Can anyone say if I pass 20, 20 as an inputs, what would be the output for the addition? Simple question. Can anyone answer? Okay, before that, meanwhile you answer, let me store this. Let me save this. Driver.java, class name dot followed by .java extension. Okay, after this, let me perform the compilation. Java sys -d driver dot. Can you tell me what is the output if I do this? 40. Yeah, good. Very simple question, huh? Very easy question I am asking. Okay, I will raise the difficulty soon. Okay, now I need to perform the execution. What is the command for the execution? Now can you tell me? Now if you see, guys, if you see, I have compiled this. Okay, now if you go and see the compilation, okay, if you go and see the folder, a separate package has been created for the main method, which is what? CILC. Inside this I have placed my driver class .class file. From here I am trying to access what? From here I am trying to access the calculator functionality, which is one of the functionalities are addition. From here I am trying to access the addition. Okay, if I want to run this for the execution, what is the command? Can you help me? We know what is the command for the compilation. For the execution, what is the command? Anyone? Execution means Java space, you need to use the class name. but this class name is part of a different package. This class name is part of this package. So how do I execute this? Anyone? I hope you are able to understand my question. Compilation command, we know these are the compilation commands. Okay. How do I execute this current class? How do I execute this main class? Java space driver is enough. Can I just say Java space driver? If I say this, the compiler, the JVM will not be happy. The software will not be happy. What can I say? No, I cannot say this. Think and tell me. Think and tell me. Okay? Whenever you are using packages, always remember. Okay, so this driver is a class, and we have developed a dot class file. Okay, after compilation, dot class file has been generated. That dot class file is placed inside this folder, cals folder, right? CALC folder. Inside this, the dot class file is there, right? So the command has to be what? Cals dot driver, right? You have to give the instruction that this driver dot class file is inside a package called cals package. Then only the system will recognize. No, do you agree with me, or do you don't agree with me? Who is agreeing with me? Who is agreeing this? 40. Correct. Yeah, correct. Okay. Now you got 40. Now the Lakshmi's functionality has been tested successfully. Now, if you go back and see the theory, so we have tested, we have understood one thing. What did we actually understood? We have understood the second one, import package dot class name. This thing we have understood. This one, import, we are able to import what? Package dot a specific functionality. Class name, addition is the class name, right? So similarly, now look at this. Instead of importing each and every class name, I can directly use a star, dot star. If I use dot star, okay, let me, if I ever have to use this import statement, okay, if I use dot star, what is the name of our current package? Okay, let me replace this with calculator, right? Calculator is name of our current package, right? The moment I use dot star, it means it has access to all the packages that is in, all the classes that is inside the calculator package, which is what? You have addition, okay? You have subtraction, okay? You have multiplication, and you have division. Okay? If you don't like to do this, if you want to say, if I want to test the subtraction functionality, I want to import that. Import calculator dot subtraction. Okay, if you want to test the multiplication functionality, I want to import that separately. Okay, multiplication. If you want to test the division functionality, I want to import the division. Instead of doing these many imports, I can directly use what? I can directly use calculator dot star. Okay, all the classes inside the calculator package I have access to now. Now what? Now I have access to all the classes inside this calculator package. Able to follow? Yes or no? Have you understood the first import statement? If I just use star, it means you are able to get access to all the package. You do not want to individually specify which package you want to get access. Hope this is making sense. Or else, if you like to, it's your wish. If you are good enough, if you are good in typing, you can do that also. If not, you can do this also. Right? All the packages you have access. What is the proof now? Subtraction. Let me take obj1 equal to new subtraction. Okay, object is created. Now by using this obj1, I can test the subtraction functionality. What is the name of the method inside the subtraction? Okay, sub is the name of the method. It is accepting two parameters. Sub, okay, 100, 20. Okay, what should be the output now? What should be the output? Let me tell you something. I will explain you the object creation in the future. For now, try to understand the concept behind this. Okay, we are understanding the packages. Can you tell me the output? Let us see who is going to give me the right output. Only 80, yeah. Okay, the right output is going to be 4080. Never mind. So this is also included now. Addition is also included. Subtraction is so two functionalities we are testing now. So for every time we need to do the recompilation. Driver.java and compilation and execution. 4080. Understood? Yes, no? Right? Now see, with this star statement you are able to. Now let me see if I am not using this star, if I am just using calculator dot, only if I am doing calculator division. Okay, so I'm importing the division functionality, but I am trying to test addition functionality as well as subtraction functionality. If I do this, okay, compiler will get mad. Compiler will say what you're trying to do, I'm not able to find addition. Okay, I'm not able to find subtraction. Why it is not able to find? Because in the input statement you have used only division. It can recognize only division, but not addition, but not subtraction. How to avoid this? Either I can use this one, I can use what? I can use directly star. Okay, now look at the third one. Okay, now third one, you do not want to use the import statement. You want to use what? You want to use the fully qualified name. Let me remove this too, or else I can say let us keep this. Okay, let us keep this calculator dot addition, and let us keep this too, calculator dot subtraction. Okay, now with these two import statements, these two functionalities will work. Now I want to test the multiplication functionality. Without importing, I want to test. Is there a way for us to test? New multiplication. Okay, the moment I do obj2 dot mul, if I pass two numbers, something like 10 into 2, 10 comma 2. Okay. So what would be the output? Output would be definitely error, because the main thread will not recognize this multiplication functionality. It is part of a calculator package, but you haven't imported that. You have imported only addition and subtraction. Multiplication is not imported, but still you want to make this happen. Still you want this functionality to go. Still this want to be tested without any errors. In that cases, you will use what? You will use a name. You will use a import called the fully qualified name. This last one, by using fully qualified name. What is a fully qualified name? Very simple. Package name followed by class name. Okay. Directly you will use package name here. What is a package name? Calculator is a package name. Okay. Calculator package name dot class name obj new equal to again package name dot class name. So this is representing what? The fully qualified name. If you do not want to use the input, you can do this also. You can use a fully qualified name. What is a fully qualified name? You want to access any class which is in a different package, use that package name dot operator followed by the class name. Okay, this is called as what? The fully qualified name. You can do this, or you can add another import statement instead of doing this. This is the third way of importing. Right? If I save this, okay, now what would be the output? By looking at this, can someone help me with the output? Come on, meanwhile I will perform the compilation. Help me with the output. 40 80 20. Good. 40 80 20. Very simple now. Output is going to be 40. Are we sure? 40 80 20. Now we have understood what is fully qualified name and how to use import statements. You can use import statements in three ways. One is what? Directly use the class name. If you don't like to get access to only one classes, if you want to get access to all the classes, okay, go for this dot star. If you don't like this too, okay, you can remove this also. And you can use what? You can use fully qualified name on each and every class. Calculator dot addition, new calculator dot addition, calculator dot what is it? Calculator. This is also correct. Okay, now the team leader is able to test all the functionalities successfully by using what? by getting access to the packages. How did he get access to the packages? By using what? By using import statements. They used this import statements. The moment you use this import statements, a barrier will be created. Okay, a bridge will be created so that the main thread will get access to the remaining classes with that barrier. How this bridge is getting created? With the help of what? Import statement. Availability is there. Okay, able to follow? Right. Now, can I say that? Can I say now? Let us say that. So we are part of, okay. Your team leader is part of alpha team, right? Tomorrow, there is another team called beta team. So this beta team need only the beta team only wants to get what? Get the functionality of addition. They want only the additional functionality. Okay, they can just reuse this. They can reuse this by using the import statement. From a different team, if they just want to get your functionality, the function that has been developed by Lakshmi, they like their functionality, they like the performance, and they just want to use that for different purpose, not for calculator application, for different application, but only addition function they want to use. They can use what? They can use the import statement. Can I say that internally in project there are many modules, many teams. Based upon the requirements, your function can be used by them in the future. Your function can be used by them in the future. Okay. Can I say that reusability is happening? Why reusability is happening? It is possible only because of packages. You are organizing the things, you are placing the .class file in the organized fashion. You are keeping things organized. Because of that organization is able to be achieved with the help of packages. And if another team members wants to get access to your functionality, right? So they definitely they import your functionality with the help of import keyword. This concept is called as what? Reusability. Don't you think that it is making now, these two advantages are getting justified? Reusability and modularity. You know what is modularity, and it is also justified. What about security? To understand security, we must understand how to create sub package. What is it? What is a sub package and how to create sub package? This understanding is very important. What is a sub package? A package within a package is called sub package. Why one has to create a sub package? That is a follow-up question. I've understood what is sub package. Why one has to create a sub package? What is sub package? Why one has to go for sub package? See, for example, if you want to track someone's location, this is a real-time analogy, right? The location can be tracked step by step. You know what I mean? Step by step means if you are if you are living in India, right? So first they track the country. Country will be tracked. Then there are many number of states in India. Okay, state will be tracked. Okay, then district will be tracked. Right? Then what will be tracked? Then the respective city will be tracked. Okay, and the respective location will be tracked. There is a hierarchy, right? There is a hierarchy in tracking the location. It's a hierarchy from high level to low level, from big to small, tracking the location. Right? Or else I can also say, if you want to, store some data in your system, if you want to store some data in your system, or if you want to provide some security to your data in your system, right? So you do what? You create multiple a folder inside a folder. Right? So there will be a folder. If this is the data, this data will be placed inside a folder, and this folder will be placed inside another folder, and this folder will be placed inside another folder. Like that, you assume that this is going to be secured. Okay, the right data is going to be here, and this right data is going to be placed inside different folders. You to follow, right? Same way you are going to do for the sub package. But why one want to create sub package is the only one keyword that you can keep in the mind to avoid naming conflict. To avoid what? To avoid naming conflicts. For example, I'm living in Chennai, guys. Okay, I think this example will make more sense. I'm living in a Chennai. Okay, let us say that this is Chennai city. Okay, I have many friends in Chennai. One of my friend is calling me over the phone. Okay, he's calling me and saying, "Hey, Macha, can you come to beach?" Okay, then from my perspective, I usually visit Marina Beach. Marina is one of the beaches. From my perspective, I usually visit Marina Beach. From my friend's perspective, he is already there in Akkarai Beach. What is happening here? Naming conflict. There is no detailed specification. Naming conflict is happening. So we are thinking about the beaches, but there are many beaches in Chennai. Marina is one among them. My perspective is Marina Beach. I visited there and I called him. He says it is not Marina, it is Akkarai. There is a conflict is there or not? So even in Java also, when you are creating when you are creating a method or when you are creating a class, for example, in our example, Lakshmi has created, guys, it's already time. Okay, please rejoin. Okay, this is very important. Don't just escape after the class. Huh? Just rejoin because Teams application is not allowing me to schedule it for more than 1 hour. Once you get knocked out, please rejoin. Don't escape. Huh? She what Lakshmi has created addition class, right? So Lakshmi is part of alpha team. So this is our assumption. Okay. Likewise, parallelly, okay, there are high chances that in the beta team they are going to keep the same class name addition, right? So in one company there will be many teams. Each and every team is going to have their own names, right? But at the time of naming classes, there are high chances that the other team members are going to have the same class names like we have now. So we have addition. Okay? It is not like this addition is going to be limited to the one class. We are not sure. In future, there are many developers. Some developer might be working on a different thing, but is going to keep the name as addition. Name of the class as addition. Right. So there should be a way to what to coexist. There should be a way to coexist these two classes. Okay, my voice is very bad. I'm hearing my voice. It's really that bad. So addition, right? There should be a way to coexist. Okay, even if the beta team number is keeping his class name addition, even the alpha team keeping the class name as addition, there should not be any trouble. Both should coexist. Coexist. How it can happen? By using sub packages. Using what? By using sub package. Or how to create a sub packages. So what is the typical way to create a sub packages? First of all, I will tell you how to create sub package. Then we will understand its important in detail, more in detail. Right? So I want to take a class name. A simple class I am taking. A package, a package inside a package. Okay. Usually, if you want to create a sub package, there is a rule. Let us say that if my company name is my company domain is www.balajit.com. Right? Or else let us say that the team name is, so alpha is the team name. Alpha is the team name. Or else let us say that www.alpha.com. Okay. So it is highly recommended to reverse this domain name. Reverse this domain name in the sense. Thank you for rejoining. Give me a minute. I will let everyone in. I think today no escape is everyone have joined. Okay then. See, See here, if this is my domain, okay, this is our group domain www.alpha.com. Just reverse this domain, com.alpha, alpha dot. What I want to keep here, okay, com.alpha dot. Let me keep it simple, com.alpha. A package inside the subpackage com.alpha. I'm reversing the domain name. Why I'm reversing the domain name? Very simple. You're working for the Facebook application. If you're working in the Facebook industry, facebook.com. If you want to create any functionalities, they ask you to create a package by reversing the domain name to get the uniqueness. Okay, under Facebook there will be many teams. There will be many team names. Like here we have alpha, beta, gamma. Like that, they used to keep many teams name. So they ask you to use the team name, or they would ask you to use the functionality name. If it's calculator, they would ask you to use the functionality name. Or if it is verification, they would ask you to use the verification name. Or if it is if it is the authentication, they would ask you to use the name of the functionality, the natural functionality name, authentication. Okay, when you do that, you would avoid the naming conflict of the classes. So let me see, let me show you. If I do this com.alpha, I keep the class name as public class. I'm keeping the name of the class as common. Common is the class name. Okay, public class common. Let me save this file. Save. Save. How do I save this? Class name.java, right? Common.java. Okay, it has been saved successfully. Where is the proof? If you see, common is the class. Here is the proof. I want to compile this. Now, if you look at the compilation, the process of compilation is going to be what? Same only. Java C space -d space dot space common.java. The moment I do this, compilation is successful. If you go back and see, okay, what is my package name? Com.alpha. What does it really mean? There is a package inside a there is a sub package inside a package. So a com folder will be created. Inside that, alpha folder will be created. Inside that, common class name will be created. Right? Com folder, alpha, inside that common. Okay. If you are doing this, what would be the happen? So our team name is alpha, right? Okay. Our name of our team name is alpha. So we are trying to create a package. Because of this, what is happening behind the scenes? Okay, what is the class name? Class name is common. Class name is common. What is happening behind the scenes after the compilation? So this is the .java file, so common.java. So you perform the compilation, right? So what compiler is going to do? What compiler is going to do? It will check for the packages. Okay, it will create a folder, com folder. The name of the folder is going to be what? Com. Okay, inside this it will create the subfolder. It's going to be what? Alpha. Okay. Inside this it would place the generated .class file, which is what? Common.class file. Common.class file. Okay. In future, if some other team member wants to use the name common, some other team member, okay, what he will do? He will create a package and he will use com dot. His team name is going to be beta. Okay. Inside that beta is going to specify the class name as what? Common. Okay. Because of this, the same thing happened. Because of this, the same thing that has happened here will happen. Okay, but the common dot class is going to be in a different folder called the beta folder this time. Previously, it was inside the alpha folder. This time, the different team members, because of the package creation by a different team member whose team name is beta. Okay, whose name is beta, the common dot class file is going to place inside this folder. Now there is a differentiation. No, if in future your team leader is asking you to import the common dot class, Okay, you would ask him, okay, which common dot class you are asking, right? There is no naming conflict here. They would say the common dot class file, the functionality of common dot class file inside the what? Inside the beta folder, inside the beta package or inside the alpha package. Okay, because the name can be same, but the functionality can be different, right? Both names are common, but the functionality can be different. Which functionality we are specifying? That functionality can be differentiated by using the sub packages. The more sub packages you create, it is like the less the chances of naming conflicts would be very less. To avoid the naming conflicts, that is also one of the reasons why Java is recommending to use the follow the sub packages concept by reversing the domain name. Okay, like this com dot. The more sub packages you create, the less naming conflict that you're going to face. Very simple. Two or more classes have the same name. Okay, different developers create what? Different developers create the class name of different create classes with the same name. Provide the name and config in Java. Packages are used to provide what? Unique namespace. Right? Namespace. So this is the reason why the creating the sub packages are very important. Yes, no, are able to follow? Right? Tomorrow we will understand the remaining things. What are the remaining things that we have tomorrow to be discussed? Okay. See, we have understood how to create a sub package. Right? Tomorrow we will understand why it is security, why it is addressing the security things, why there is an advantage of shareability, and what is this abstraction. These three things we'll complete tomorrow and day after tomorrow. Then we will start writing the first Java code. We'll understand each and everything, what is class, what is method, and we will start discussing from there. Okay. Any questions for me for the day?